joining. It's a great turnout. Very excited to be facilitating this session today. Just a little side note, we are recording this session, just to let you guys know. But yeah, so we are going to be keeping it very current today. We're talking about something that's been quite a hot topic recently, which is Agentic AI. Some of you might be familiar with the term and you've seen it all over social media, and you've seen tech companies kind of racing to put their agents on the market. And there've been like a flood of products coming in. Jay actually sent me a post on LinkedIn recently. We'll get to this in the presentation later on. Immense. And they range from voice agents to the customer service agents, sales agents, and like productivity agents, things for data analysis. With the rise of all these agents, it seems that there's actually been a lot of receptiveness from businesses. About 26% of businesses are already adopting autonomous AI technology, which is huge. And I think it also signifies a shift in attitude towards AI. Before this, it seemed that businesses were still hesitant to adopt AI in their systems. So we're going to be breaking this all down today, getting down to what Agentic AI is and how it can impact business, and what some of the misconceptions might be that are floating around, and how some of the concerns can be solved. I'm going to be talking to Jay today, who's our founder. It's going to be a very conversational meetup. Anybody who has a question, you can either speak up or just pop it in the chat and we'll get to it. Jay, I think we can jump into it. If you can start off by giving a breakdown of what Agentic AI is and how it's come about.
What I thought I'll do is maybe just share my screen, Jess, if you can see that I'm in the right meetup. I should be there. Am I sharing it already, or is it not?
It looks like it's coming up. No, I don't think you're in the right. Wait, there are two of you. If you start sharing, it should bring up now.
Yeah, so what I thought I'll do, based on that introduction, thanks, Nicola. And yes, people who've been attending these kind of know our style. Some of them are very free flow. And so what I figure I'll do is use some background material just so that we all get a feel for how we've seen this approach and how it has affected, this space. And when I chatted to Nicola earlier, I said to her that, agent-based modeling and the concept of agents have been around, for a pretty long time. And I was exposed to it first in the 90s when manufacturing companies wanted to optimize productivity inside a manufacturing plant. You would run agent-based modeling approaches to figure it out rather than agents in the real world. So the concept of automation of work has been, something that we've been thinking about for a bit. If we create a basic grounding definition set that we can work from, these definitions come from various sources, mostly public sources. One or two come from NVIDIA, like the autonomous agents that use agentic capabilities. The way to think about this is most of the concepts in technology, in any kind of automation or even digitalization, is to automate work. And that means the ability to find an approach where whatever you implement can do more than a human can do and can do it faster. So that means have a higher level of productivity. So that means that dealing with accuracy and preciseness, and we kind of all know that already in the way that we've been using technology. The basic definition of an agent is somebody that acts on behalf of somebody else. So that means that an agent would be able to get work done by applying either a human or a system, and the decisioning will be centered around deciding what good and bad looks like. An agent initially will start with a basis of some kind of heuristic. They'll have an understanding or an education or a purpose they want to fulfill. They would decide at what point they invoke what kinds of work to produce an output. If you understand that, the agentic world does make a lot more sense, because in the agentic approach, it is about the way in which you can use various kinds of intelligence, not just artificial intelligence or human intelligence. You want to use a combination of capabilities where a human can interact with some kind of environment, and the work that needs to get done can be organized. The intent is that in an agentic environment, you can automate that. So that means that agentic AI is doing this in a way that you can do it linguistically. You can speak to it, talk to it, engage with it, and extract the intent. And from the intent, get some kind of autonomous activity initiated, so that the autonomous agent means that, take the example that Nicola raised earlier, I want an agent that's going to track a certain stock. And if the stock performs well, or I set a series of rules around what performance means, I can get it then to execute on a trade for me. The confusion at the moment is that people think that all of this is going to happen automatically, and it doesn't. You need to design agents incredibly deliberately. You need to create sets of rules. You have to provide guardrails. You have to provide it with the right data. And if you want anything that is going to be accurate and precise, you have a very different strategy and a decisioning cycle than if you engage with something that is more linguistically useful. So by the time you think through this, we really agonized over this and found that you can't just take a generic agent or a generic approach. You need to have a multitude of components together. And that's why the kind of ecogentic framework emerged for us. And we've been working on it now for quite a while. It's, quite a while in this space obviously means about 2 years. So it's, in the old days, you would have said quite a while. It'd be like a 10-year journey to get somewhere. So how do you get an agent-based framework that you can include whatever is special to the situation that you want to deploy it in? People who know us know that we focus heavily on behavioral human engagements, interaction sciences, spend and money personalities, those kind of ways, intelligent sales. So that means, how do I engage humans continuously? Can we take those capabilities and make them natively available to the agents that will then perform work in the context of its journey, and make sure that those can be invoked dynamically? If I'm having a conversation with a bot around what's the best option for me in taking up a loan, if I'm a bank, say, I can automatically go pick up your spend personality, go pick up your money personality, make a decision about who you are, fetch your actual balance, get your credit score, bring all of those elements together, make a decision about the answer, and give it back to you. So the idea is that there's almost this strange intersection between workflow and what happened with the RPA world and all of the people who are involved in flow work, and our agents are busy affecting that. So I think, Nicola, that's kind of how we maybe need to look at it from a starting point.
Yeah, I think that makes it pretty clear. And I think it also addresses some concerns that businesses might have. Having an agent in your system, you think, what if it decides that today is the day we use business funds to buy a Ferrari instead of fixing office infrastructure? It's a question that comes up for a lot of people. And I think we can get to how Ecogentic can solve that problem later on. But if you could maybe give us a better idea of what the landscape currently looks like and what's out there and who's dominating the space, I think that might give people a good idea of what they can look out for.
So many reports have been published as to surveys that were done and comments that came back from people. And I think that there is a slight bias, and probably a research bias or a selection bias, around people wanting to automate everything with AI. So that means finding an approach or find various approaches to reduce the number of humans in the system. And in that, obviously trying to drive profit up and cost down and complexity lower and all the things that we all always care about. But the reality is that if you look at this side by Capgemini, and I have a slight course with it on one end, and the other end I kind of agree with it. The one end is that early AI systems have not really started in 2023. It's been around for a long time. And actually, we were just looking at a model that we used to use called GPT-2, for those who can remember that far back. That model was published 8 years ago. 6 years ago, it became available on Hugging Face. And GPT-2 still today, if you look at it in the last month, had about 2 million downloads. So that means that people are still very interested in the origin of this thing called a next token generator in the world of generative-based AI approaches. So I think there might be a slight misconception around how long this has been around on the journey we're on. We are quite mature in how the models work, but getting the model to do something accurately and not deviate, like the example Nicola just used, is a very big challenge for everybody. So that means that this AI agentic systems approach we're in now is to say that if I can detect the intent a person having a conversation with me, and the intent is about something that's got to do with, let's say, accuracy. I want to know what the balance is on my account last week. Why? Because maybe I had a tax year end, or maybe I want to understand how many times I spent money on food in the last year. It's a very precise thing that it needs to perform in the back end. So the work that needs to be done is definitely not going to be a model. It's something that has to go and fetch evidence that it knows that it's pretty exact, and then it needs to merge the evidence that it's found with the language that is used by the person engaging in that moment. So that means that if I ask how many times I spend money on food, but then if I say, give me a recommendation as to what the best option is for me to do traveling this year, I need a loan to do that. Now what it needs to do is to need to figure out the fact that it's not accurate and precise, that it's not a set of options. It needs to go to a different source because the intent is a recommendation. So it now needs to go find a source of where it reliably can pick up what the options are, compare those options to my balances, check my credit score, bring all of these elements together, and then provide me with a set of options that are relevant to me. If I then say, well, yes, I would take up this offer, the next piece of work that must be done will then probably initiate, depending on the regulation and so on, maybe a human in the system. So that means the agent needs to be part of a swarm of agents that will then initiate other kinds of work. And that is really the current stage that we're in. If you deal with intelligent sales as an example, and somebody is asking questions about what is the best device that I should buy if they're busy looking at their telephony options and they want to understand what the variations are of memory and the like, there are certain attributes that are very specific to the questions you're asking. And I think people don't often understand that. This phase that we're moving into now, what's called multi-AI agent systems, means that we're seeing the commoditization of the generative stack. Access to all of these models and what they can do is not really a competitive advantage anymore. Everybody has it. You all have access to it. Most people run Lama on their desktops already, or you might even have access to Grok for high-speed, cheap access. You might use OpenAI or Anthropic, Gemini, or whatever option fits for you. That part of it has created a platform thinking approach. On top of that, we're trying to figure out what we can do with this. The players that have emerged, we all know about them. All the big players jumped on the bandwagon. They all spent billions in infrastructure upgrades. There are agents figuring out how to do better coding and how to do all of those kind of things. But what we're really seeing emerging as the major focus are vertically specialized, business-specific agents that can be deployed securely in various settings. So that means it's not just something you're going to get embedded like a Copilot or go to Anthropic and get your agent framework there, or you're going to do a custom GPT and use some of the background agent work. What you're going to want to do is find ways in which you can get agents from various sources, various places that can assist you rather than finding this one size fits all. So I think that there's almost this complex dilemma where people on the one end believe they're only going to sign up with one cloud provider. I'm only going to be using one language model. I'm going to standardize that, and then I'm going to create what I do on top of that. We see exactly the opposite. If you look at Gartner, Forrester, and some of the top researchers, and even Anderson published a research note late last year saying that they now are seeing this deep fragmentation of intellectual-based execution. So that means artificial intellectual-based execution, AI, and how that will assist the business. But that means that you need a new approach. You need to make sense of where the agent would fit, if it's going to do service, if it's going to do something that's going to be to do with your productivity or whatever the scenario is that it's going to work. And that means your complexity around the ecosystems you need to manage is going to be an entirely different problem, especially in the enterprise setting going forward. Historically, enterprises go through cycles where they're trying to standardize and simplify. And as new inventions come along, it fragments and it opens up. So that means that you need to have a strong understanding of the architecture you're going to be using, where the security is going to fit, how the journeys are going to continue into the future. And that means that the agentic mesh as an approach is going to become one of your primary priorities. You're going to have to know where are you going to find your agents to make sure that they are reliable, secure, they can perform the work they need to perform. So you're going to need access to marketplaces, and maybe even in your own organization, you're going to have a marketplace with a number of different agents. Like an example is, if I think about it, we've got about 100 or so custom GPTs. We've taken every major bank that we deal with, every major telco. We've created an agent to behave like a McKinsey and a Bain consultant. We take all the knowledge from the consultants. We brought those two together, and we asked the agent to say to us, please explain to us if this company is going to benefit from offers that we give them. Will the agentic story fit, and can we help them with the customer service delivery? It then does an entire consulting piece in one question in a minute, and the job is done. Because the work you're replacing and the agent doing the work encapsulates the intelligence of what historically was very private and only sat with a number of people. But that means that if you want to have some kind of marketplace or a catalog, so that means your registry of how you're going to decide what works and what doesn't. If you have an agent that hasn't gone through all the security checks and you only want to use it for kind of experimentation purposes, it's got a very different approach than if you're going to use something to help with, let's say, a credit score or somebody that's going to help you to pick a price for a client's product. So you need to separate those based on your ontologies, and then getting them all to work together is one of the primary challenges. That means, can you create a journey, a roadmap, a means by which you can create a guardrail that will stop the agent from doing things that it's not supposed to do, and you want to have a hard mechanism to stop them, especially if you operate in a regulated world. So by the time you make it be accessible, you're going to have a very different set of security rules and a very different architectural decision that you need to make around how you're going to test it. So maybe, Nicola, this is the last point, mention this, that decisioning is playing out at the moment, saying that various industries are looking at this. We see that for the 2025 period, and the study concluded at the second week of January. So who knows, people are answering the correct thing or not. But for now, what we can see is that it is an important topic for this coming year. Last year, everything was just around making sense of how we're going to use some of these tools and what it's going to mean. Now, I think people are interested in the use cases, the benefit on the ground, the execution, the effect, the things that you want to achieve in your business. Maybe that's the way to explain that, Nicola.
There was something that you said earlier today, which was that it is, well, multi-agent systems and AI agents are intelligent. Like generative models, you said earlier, are not intelligent, and AI agents are. And I think that's a lot to take in for businesses, because you've got these autonomous systems who know how to do things for themselves, and they're also talking to each other, so they're iterating off each other, having conversations and trying to collaborate or have conflict. I don't even know if that's possible, but it feels like there's a lot of alarm bells going off there.
Maybe just to take that comment from earlier, I'll give a philosophical perspective. For those who are interested, you can pop it in the chat. It'll be good to talk about this. I think when we don't know how something works in its core, like when you train a generative model and you use deep learning to do that, and you set your hyperparameters, you decide how many layers you're going to have, you want to have in the context of your latent space-based parameter for your layer, and you train it through a number of epochs. And what I found I do in a classroom, I create what's called a micro model. I take like 20 lines of text and I get a model trained on that, and then let people do completion on it. You then realize very quickly that with backpropagation, gradient descent, and many of these mathematical algorithms, the model itself is just the way that you encode and the way that you take a very complex input body of text, if it's text, image, or sound. You find the commonalities, and the latent space contains essentially all the common patterns that exist in the input. It has no reference to its source. It has no reference to where it comes from. If you ask a generic language model about certain academic concepts or whatever it is, and they're not popular, it will get it incorrect because it's in the architecture of the design. It doesn't have the concept of intelligence in its design. To make it intelligent, if you think about how humans work, if we don't know something and we want to find a fact, we know that there's a researcher or somebody cataloged it or somebody put it into an encyclopedia, Wikipedia, or the like. The intelligence is the agent thinking about what they need to do, figuring out that it doesn't know the fact, then know that it needs to go fetch the fact, and then once it knows the fact, it needs to take action. So that means the intelligence, in the way that we kind of looking at it, is saying that the intelligence is far more focused on bringing all the elements together rather than just saying a language model is intelligent or a generative model in the context of a language model. That's because it's not really intelligent. You need work to be done intelligently, and you need it to assist you in deciding the intent of the action and figuring out the accuracy and preciseness and the linguistic plausibility of various areas that you're going to be focusing on. So maybe I can show one or two examples just to start in our context. Nicola, should we do that?
Yeah.
Okay, so let's look at a couple of examples. So the first one is just that, some background. The large language models and the capability of what a generative model is. Generative model means I take a series of inputs, go through various cycles of training through encoding, and create, in the context of a checkpointed model, what's called a transformer. And once that transformer is deployed, I can then use it either to generate tokens on the back of the transformer, or I can add a chat layer on it to make it have conversations with humans. But the point is that it is pretty good at taking a context known as a prompt, and asking it something and let it classify conversations and let figure out what you're trying to do. So that means that point A is the era that we come from, taking an input, let a model do the work, getting an output. Point B is saying that, hang on, if I ask a question about the current stock situation of NVIDIA, Investec, APSA, Cell C, Vodafone, or whatever the company is that I'm going to want to look at, it's not going to know what's going on in the moment. So that means that the agent needs to figure out what action to take and find the evidence. Once the action comes back as an observation, it needs to know what to do with the observation. So that means you want to bring it together into like a multidimensional space. By the time you then get to cognitive language agents, that is what you see with explainability. And that is what models like DeepSeek and GPT-4o1 are focusing on, is saying that what I need to do is take the problem statement, unpack it step by step, and then figure out what you need to do with what happens after that initial question was asked. So that means I need memory as in a human, where I want to selectively remember and forget what is not useful. I want to apply reasoning. That means that apply a heuristic or a model or a practice. And I want those to decide what actions I can invoke on the environment to get an observation back. So that means that some of the reasoning approaches, and I'm not going to go through this in detail, let's just see that it's kind of indicative. But, on the far left, it's like the vanilla pattern typically for these kind of reasoning models is to say that I provide it with some context, I get the thinking going, I let it decide what it needs to do, and it provides me with an answer. In this context, it's kind of like a scientific agent that does work. If I want to use RAG, so that means some kind of retrieval augmented generation, where I'll go fetch evidence somewhere, include it with a model, obviously it performs better. And the last one is to say, well, what I want to do is reason within context. I want to take every piece of intelligence, let the agent do work on its own so that it doesn't make a mistake. And once that's being done, I want all of that to feed back to the main journey of conversation. So one of the ways to look at this.
But before you move on from this whole topic of reasoning and thinking, Etienne has a question about DeepSeek R1 and its ability to think and reason and explain how it's thinking and then give it results. And he's asking if that is not a step closer to becoming more like how humans think.
Potentially. But the problem is that humans, the perfection in the human intelligence lies in its imperfection. And that means that essentially your ability to selectively forget based on an emotional state, an incentive, a need, or purely the fact that you just don't want to remember something is what creates an ability for a biological system to function. So I think that if we take human intelligence as the benchmark, then we are pretty far off because we've not been able to figure out how, I guess I'm speaking for the discipline, I should just speak for my understanding of the discipline, because we have not found research currently that shows it, and especially not, like what DeepSeek is trying to do is just basically copy what's happening in GPT-4o1, where it breaks up the initial question into various types of intent, where it takes the output and passes it on to the next cycle. So I think that you still need to understand the purpose of that highly focused intelligence, even if you're going to get to a theoretical point of AGI, of some kind of artificial general intelligence. We don't know exactly what that looks like. Last year in California, I sat through quite a few workshops on this, and this has always fascinated me, is that there is no common agreed upon definition of what intelligence really is, firstly. Secondly, there is no commonly agreed upon definition of what the concept of consciousness is in the context of this domain. So yes, there are competing, if you look at it, when I read a literature survey the other day, it was like reading the top 100 definitions, and everybody has their own way of looking at it. And because the human system is so messy, and obviously why we are so deeply interested in it, you don't quite know exactly what it means. All that you know is that humans function in the context of the actions that they perform, the evidence that they leave behind, the work that they do, essentially is what is being replaced by something else that can do the work the way the human used to do it. Maybe Etienne, you and I have debated this a couple of times. Human bias is to forget, and human comes with its prejudice, its bias, its history. And the other thing about a human that is interesting is that if you compare it to an AI does not have nostalgia. It has no understanding what happened to it 2 minutes after you booted it up. It has no concept of a human's biological history. When you look back at your childhood, the chemistry and the way that the emotions create endorphins and everything that happens neurologically to the human, there is no known computer architecture that can replace that at the moment. So yeah, that does make it a bit more complicated.
That opens a whole can of worms.
Listen, we can do that in one of the future discussions, I think.
I see there's a hand up. Wolfgang, do you want to speak?
Hi, thank you. Thanks, Jay, for all those insights. Just something interesting that I've gone down the rabbit hole of DeepSeek. What's interesting is that it's actually a project, from what I understand, that they use the larger language model, i.e. ChatGPT, to train the smaller language model. So even if you
use data,
if you go to DeepSeek and you actually ask it, who am I? It will come back and say to you, I'm ChatGPT, which is, first of all, quite interesting. But more interestingly than that is that apparently these Chinese developers who developed this only spent something like $6 million doing this, where obviously all the rest spent billions, and it's not much better from what I can see. Don't forget about hallucinations, though. They may not have any history of emotions, but they definitely suffer from hallucinations.
Using synthetic data to train models is a pretty common practice, and especially the models that were trained by Meta went through basically creating a model where the purpose of that internal model they trained was to create training data. The same thing happened with DeepSeek. If you read their academic research, they show it pretty clearly that they've generated the data sets that would normally be needed for a linguistic model to function. Remember that the purpose of a language model is not to be accurate or useful practically from a fact point of view. Its purpose is to be linguistically useful. Then what happened with the Lama models, they quantize it. So you can get a Lama 3.2 model that is about the same as a GPT-4o mini, about 60 megabytes you can stick on somebody's phone. There's this race at the moment to compress the models, make them available on the edge device, and then use them. The concept of ChatGPT means this is a chat generative pre-trained transformer. So it doesn't mean that it's saying that it is the brand, because the ChatGPT is not the trademark name. You can use it yourself if you wanted to. And the reason is because they never could get it, registered, because generative pre-trained transformers was actually created by Google and it was published publicly. So if you ask any generative model what it is, what it does, what it feels, remember, it knows nothing other than a bunch of tokens in a latent space and a hyperdimensional space. It's found the quickest path to give you a response back. It's not like a human. When you look at it, you think, oh, check, it knows what it's thinking. It is not thinking. It is generating the next plausible token based on the back propagation that was applied initially and the gradient descent giving you the local optimal scores that then gives you a result. So it's not like it's intelligence the way that humans sometimes think about it. Yeah, that's maybe just a way to think.
Cool. I think that was a very enjoyable sidetrack. Thank you, everyone. Cool. I think maybe we can get into some of because obviously agents they use a bunch of other capabilities to perform their tasks. So if you could maybe talk a bit about how you can equip them with these capabilities and how, okay, cool, go ahead.
So what I can show, so this is an example of work we've done over the last while, and this is an agent-based modeling environment. So that means that it's got the modeling piece of it, not an agent in the context of a real-time production. So I want to look at the two kind of worlds side by side. So in this example that I'm going to go through, this is a game-making tool. So that means in the context of gaming, it has got an artificial world, and you can decide what the artificial world's parameters are. So if you design a game for public, let's say you want a game on your phone or a game on your PlayStation, whatever it is, there are normally as rules. If you play against other players in the world, you then create the kind of dynamic situation of people behaving differently. If you want to create a simulation of how people move around, let's say your casino, like in this case, this is done for a company called MGM Grand in Las Vegas, and you want to see how humans would move around and what the impact would be if the itinerary that gets predicted for that person, using a selection approach to pick up, is this person more interested based on their behaviors in something that's got to do with a show or a restaurant or a bar, or they want to go onto the floor to do whatever, game they want to do. You wanted to be able to figure that out, and you want the person to be able to chat to something and ask questions about, what is best for me. So that means that what we historically used to do, if you think about the early days of recommendation systems, you used to use, like collaborative filtering and some of those kind of generic capabilities. Now, what you do is you use both fixed and dynamic routing. So that means you want to use the linguistic interface to detect the intent of the person, work out what's best, and you only want to decide on the back end, whenever you give this person a recommendation or a price, that it is actually what it's supposed to do. So that means that bringing the infrastructure, the real world that you have, and bring it together. And then in this example, every time we want that agent to move, and you'll see it sitting, it gets given, it's asking a question, and let's say that you got congestion in the casino, you can keep on giving people recommendations and incentivize them to go to other parts of the casino, as an example. So that just means that agent-based modeling in this example means that you can test how the agent could almost be human-like, because you might give recommendations that is not what's best for the person, it's best for the casino to maybe move people from one place to another or get them to act on a certain spending criteria. The one that people have probably seen before from us is this approach. And this means that inside your custom GPT environment, you can go and ask questions. And in this case, all of these, especially the intelligent agents, will use a prompt plus access to whatever the work is going to be done with to maybe bring it back together. So in this example, I just ask it a question about a definition. But then later on, I ask it a question about what the score is for a particular customer. The work that it did there to go, start again. The work that it did there to go and call an external API is the essence of how many agents are built. So that means the work gets done by gaining access to places where you know that something can be performed, and especially in an enterprise setting. So like in this example, if it then continues, and we just get further on, you'll see here that it generated, and you'll just want to quickly show that you can't really see it. You'll see there's a little bracket behind the text there. That bracket will show you that the job was not to show the person using it the code that was generated, but to do it automatically inline, perform the work that needed to be done, bring the result of the work back, and present it back to the user. So that means that interactions, multi-steps to be performed within the rules, getting results back, is one of the primary use cases for a lot of what happens in the kind of agentic world. So here's an example of how a Copilot can be built. So for those who are in the Microsoft stack, or if you Office 365, or you use any of those kind of technologies, what you see here is that let's say that you're inside a Word document, a spreadsheet, you're inside a PowerPoint, and you want to find out a particular customer's spend personality, or you want to find out your own spend personality. You want to firstly be able to ask questions and let the agent automatically detect what you're trying to do. So like in this case, if I wanted to describe something, it will then go and fetch the knowledge in the context of how it was configured, in this case within the Azure environment, and it returns back the result for you. But if I ask it, can I do a quiz to get my own personality score? You can then skip a bit forward, but you can go through the steps to answer all the questions that at the end of the cycle of those questions, you are given a score and maybe an explanation that then comes from a different service, right? So that means that multiple components, multiple pieces are fitted together, that together then forms work to be done. In the agentic world is then basically an agentic journey, or it's the way that you can then let it also function autonomously. If I want it to work autonomously, I still need to tell it to observe for some kind of event, for some kind of input, for some kind of action. And once that's done, then let it decide what needs to happen. And you can do all of that through some kind of linguistic environment. Yeah. So kind of some background.
Yeah, I think that's yeah, it explains it very well. But I'm wondering, what are some of the things that if you were to use like ecosystem AI's capabilities specifically, how does that make it different in terms of engaging with customers and keeping things personal, even though you're speaking with a bot? If you could maybe expand a bit on that kind of stuff.
Yeah, I think maybe the way to start is that I can give you a quick glimpse of what we've been using as one of the basic kind of reasoning approaches for this. Is that if I want to do something for an individual, so that means me wanting to do it for myself, it means that I need to go and find a productivity tool or some kind of agent to do it just for me. So I want it to help me with text, and once it's written the text, it must automatically email it. Once it's emailed it, it must go check the response back. all those pieces of work have been done historically by you, maybe, or by something that you've automated in a fixed way. So that means deciding those outcomes and deciding why you decide on your dynamic interactions is kind of the first piece. The second piece around understanding how that gets done in a group. So let's say that you want to have an agent that you can get customers to engage in, and you take all customers within a certain segment, and you want to use the individual's preferences to decide where they fit. And once you know where they fit, you can then communicate with them. You can then decide what catalog item you're going to be using to assemble whatever the journey is. And by the time you want to deploy this broadly in society, you find that I still think that there's enormous value in your classical models. You're still going to train based on evidence, and you're going to use those in the context of your agentic journeys. It's not like you're not going to exclude any of the journeys that you've been on or any of the AI work that you've done. And actually, you're going to now give it life. You're going to get it to be used far more effectively. And for those who have seen this, just bear with me. I'll just spend kind of 2 minutes on it. We kind of see that a lot of the agentic capabilities that we see being deployed probably will end up in our world, at least within some of these pillars. Because if you think of the on the far left, the act of discovering, new kind of opportunities in the context of a target market where you've never spoken to somebody before. So let's say that you're driving a campaign, and a campaign is to have a conversation with a person, and through interaction, you want to decide if the person is worth pitching to or not, if the person is going to be liable, if the person is going to be, the kind of person you can pitch a certain product to. You can then do that through, what's on the far left. The far right is that if you've been with me and my company for, let's say, a year or 2 or 10 years, and I understand everything about you, I don't want to go and have an agent not knowing who you are. I need to find the evidence that, yes, you do have a mortgage, you do have a phone, you have spent with me historically. I want to understand that. So that means that we do see that there are going to be some generic journeys, and you see a lot of generic agents at the moment are very technical and very gimmicky. I mean, there are thousands of gimmicky agents that can help you design logos and go do like the one that you said earlier, make a mock trade, and obviously a lot of those are not really real. But the point is that you really need to think about where you apply this pretty carefully. So that means that if you then think of an agent, you kind of need to think of an agent having a start and an end. I just realized earlier that I don't have the reference. This is from a McKinsey paper that they kind of socialized with a lot of their financial clients around the world. So that just means that if you start using some kind of natural language interface, you need a translation of, like I said earlier, what the person wants. You then want an agent manager or an agent management environment. And I think next week you're going to see from us the whole ecogentic environment. And a big part of what we do is an agent management of all of the components that can come together to make it work. And that means that you want that agent to be able to understand what it needs to do, where it's going to go, can it check what it needs to check. And then the big part of it, can it connect with systems outside of where it functions? So that means that the agent engine operates on its own, and it will then go and fetch what it needs to fetch. As an example, that if you use Copilot in your Word document, the content of what you create is yours. It's in your tenancy. It's within your security environment. What the agent does, it needs access to that to then perform its work. So that means that, these kind of agent approaches with the journeys is kind of at the basis of a lot of the thinking. So now if we then think of agentic, that means agents that can do work through self-selection. You need to think about this a little bit differently. Now, what you need to think about on the one end is that you need something that is capable of linguistic interactions. So on the far right, you use a generative model. So that means the ability to write, to check intent, to categorize what I'm saying, to be able to converse with me in something that I think that makes sense linguistically is one side of the coin. The other side is the ability to perform things that need to be accurate. Well, accurate within statistical terms. Why? Because in many companies we work with, they're expecting those results to be explainable. And if it is explainable, you then know that you can reproduce it. And as you know, in language models or any generative model, you can never explain it because of the level of randomization. But that just means that the options that we see emerging from this are enormous. So that means the way in which we drive recommender systems, nudging systems, interaction systems, offering sales systems, fraud detection, fraud management, all of these kind of cases are non-exhaustive. They are just, open now for a rethink in the world of agents. But that means that you're still going to need to know where the dependencies lie. You're still going to need to know where the directed graphs exist. Because if something is truly dependent on something else, you don't want it to make up facts. You can't make up, Nicholas balance and said, oh, check, Nicholas Learjet is parked, at the airport, and that means that we can send the rolls. I mean, it would be nice, isn't it? But meantime, you only, got a car sitting in a driveway, and if it then decides what works and what doesn't, you need to know that the decision that it's making is based on a graph journey where one side might be very strict and another side might be more open and decisioning oriented. And over time, you can track the performance of the planes of how humans interact with you. So in our context, to maybe answer your question, the basis is that we've created a name for it called fact injection. And the fact injection just means that in my life, while I'm conducting what I'm doing, I need facts injected throughout my journey of whatever I'm doing. So you need kind of a stack that can help you with that, where you can leverage the best that's available out there. On the other end, you need to have a decisioning approach. And in your decisioning approach, you need to decide when you can get away with just prompt engineering to do certain bits of work for you, all the way through on the other end when something needs to be accurate and precise and it needs to go fetch data. And you want engines to be able to abstract this away from the complexity that exists under the covers. So the idea is that if you get that right, you can then have a framework for how you can deploy agents. And if you deploy this agent in, Anthropic's agent base or OpenAI or Microsoft's Copilot, it doesn't make a difference, because either way you need to do the work. It's not that if you use one of those platforms that you're all of a sudden going to get something that's just going to work out of the box to solve your business problem. So we definitely see that solving your business problem and the tooling that is needed for that is an enormous pressure point for many companies, because just getting their minds around agents in the context of a lab is okay. Trying to get that into production and trying to get it to do real things is an enormous journey. It's very, very complicated to actually get kind of all that in place. Here's kind of an example. If you had to use platforms like Infobip or some of those kind of environments, you still need to tell it and help it to figure out the intent in the context of what you attempt to do. And if the intent is to get something where I need to go find a fact, or I need to find a definition in a vector store, or access my traditional tools, I still need tooling that can assist me with that. And I won't be able to do that in a way like, yes, an example of one small piece of the spend personality agent that was configured. This is in the Microsoft Copilot Studio. And obviously behind the scenes, you can build this in code. It's just that you've got, thousands of lines of code per subset to check that it's actually doing what it's supposed to do. So we're definitely seeing that agents that are business specific to the problems that you're solving in your enterprise is going to be an ongoing focus, especially as more and more tools emerge like ourselves in this middle spectrum, helping to accelerate that journey. Because in our case, the way we believe that we can compete is that we're not going to compete with, something like Microsoft Copilot. We're not in the same space at all. But what we do know is that our spend personality, money personality, sentimental equilibrium, emotion genetics, all the algorithms that we've worked on over time with clients have solved such specific challenges for them that the platform companies are not interested in that. It's not their game. It's what specialists like us or like our kind of approach encapsulates into the tools. But that means that it needs to fit within your agent framework. You need an agent tool from us that can work across all of these places. And I know that, listen, for the sake of time, Nicola, I know that we a couple of minutes out, but maybe we can share some of the content quickly. This is a classical example. If you got reliable history, it's quite different the way you make decisions than if you need to learn something from somebody that you know nothing about, and you need reliable practices for that. By the time you deploy an agent conversation, you need to have a reliable method by which you can decide when it needs to be not reliable, so more generative chat, or when it needs to be very, very specific around what it needs to do. This is a chart that I showed earlier where you want to decide when it's accurate versus non, and how you can deal with a situation once you've interpreted the intent of what you worked on. And then you want to have low-code and no-code tools to do a lot of this for you. So what we've been working on is kind of a visualization journey that somebody can wire together a journey. And the example that is seen here that is not really practical, I think that will be demonstrated next week, is to show that the journey at the top, as you can see, it's got lines everywhere, and it checks the fact that the language that is passed through, the data that is moved are within the rules of the agent. But at the bottom, you just say to it, I want to chat to you. Then you can still say to it when I'm chatting to you, detect if I'm asking for definitions or if I'm asking for values. So you can decide where you draw the guardrail of the ongoing agent's interaction personality. So that means, like in that case, it's interaction environment. So here's this kind of a last slide to show that, you can start with a chat. You can follow an agent sequence that you've done in the top right, so you can wire it together. You can include voice and chat, different channels from different places. Here it shows a voice bot and it shows WhatsApp as maybe different interfaces depending on how you want to communicate with your agent. And you can also have the agent being communicated to by another system, because you can expose an API that can either trigger something. You can have webhooks to make sure that it performs certain actions for you. And at the end of it, once it's done its work, you can then present it back into, let's say, a user interface. And for those who don't know, if you go to our GitHub repo, we've got Xcode examples, Android, Python, Angular, React, all those are there, so that you can from there call any of the entry points to then get results back for the tech platform that is best for you. Yeah. And I think at the bottom line, we've just been working on a bunch of modules. For those who go to our website, you can see this. And the idea is that these are kind of pre-packaged bits of capability that are available for you to jumpstart your journey if you want to get going. And these are just some of them, but it gives you a quick way to get going.
Cool. I think that's the perfect place to wrap up. Don't want to give away too much before next week's meetup. But yeah, I think we do have 1 minute left. So if anybody has a burning question, now is the time. Go for it, Moritz.
Thanks, Jay. Always insightful as always. Thanks, Nicola. Jay, I'm just curious at a practical level. When you say implemented at a client, I'm going to use a practical. Let's take an asset leasing company who wants to communicate with clients about asset under and overutilization and dynamically allow the client to adjust their IT estate by swapping in or out under or overutilized assets as one example. And then another workload or use case would be the periodic lease renewals. How do they determine the scale of deployment? How many agents do you need to service? How many customers? I guess it also depends. It's not like how long is a piece of string, because how complex is the workflow and all of that. But then how many agents? Do you have like agents for key accounts and maybe one agent who handles many rats and mice clients? And then how do they determine how many sort of agent managers do you need, etc.? How would that look? And then also lastly, what would the commercial model behind that? Would a customer pay per agent, or would they have a platform license and have unlimited number of agents? I don't know if that information is readily available. Thank you.
Yeah, so maybe just first step, take the case that you're working on and understand, obviously, firstly, regulatory and access to data security, all that will be taken care of. But you want to understand what you want it to present to whoever it's going to be presenting it to, right? So if it's an employee or an external customer or a partner, whatever, it doesn't matter. The point is there's a human that's going to interact with it. And that means that if that human is going to interact with it, let's say through a chat interface, and the chat interface is a WhatsApp or it's an email or whatever the mechanism is that you want to do this kind of communication over, you need to understand what kind of entry point conversation cues there will be from the beginning. So if you're in an agent and the person asks, well, what's the weather? And you want to ask it to give you directions to go somewhere, or can you give me a recipe to bake a cake? You want the agent to know exactly what it is not supposed to do. So like you said earlier, if you have something that's going to specifically price for and allow the person to take an action to switch to something else, it means that there will be one part of the agent that needs to figure out, has it collected the evidence of what it needs to perform the next step in the work, because it's not a workflow, it's a graph, it's a directed graph. So it needs to know that if I have got the person's portfolio and I figured it out, I can now go to the next step that will figure out which ones are switchable. And if none of them are switchable, stop the journey immediately and pass it back to you to say that you have nothing that is switchable. Then it can, so that means decisioning that historically was done by an agent can now be done by an AI pretty reliably. And you can even do kind of adversarial, and you can do checking models. So you can have one model that makes a decision, another model that checks it in the pessimistic way, and another model that has got a series of rules maybe predefined in the context of its RAG definition to also check. So you can have multiple ways in which you can check that it's actually doing the right thing. At the end of it, if the person then gives a confirmation, and let's say the agent was set up so the person must say, I agree to you taking this action for me, what then needs to happen is you can probably use that as part of your regulatory framework. Let's say they say something like that, because the linguistic engine will pick it up. It could come back, say to you, are you sure you want to do this? Because I will move this now from point A to point B. If you accept this, it will be done. The moment they do that, the agent up until that point has had what's called agent memory. So memory means that it has got an understanding of the data that is moved within that particular conversation. So that means that if it created JSON payloads or whatever, for those who are technical, they will all be accessible, and they would have been pre-tagged in the memory system of an agent-based environment. It will then say, well, can I take this and can I apply it to the action where there is a system in the backend that's got an API that needs to be called with, person's identification, registration numbers, and security verification from and to. And it will then take that, what it's already created, create the payload for the API, call the API to do the work, get the result back, format it based on how the agent was configured to give it back to the person. So that entire sequence can be configured quite easily if you have an understanding of how it's done in the context of a human setting. The last part of let's not talk about the commercials, but the last is part of the way that you would deploy it. And you can just, the more infrastructure you throw at it, you can get every single person to work with it. I mean, obviously what you're going to want to do, manage your risk. Step one is create the pessimistic version that is very narrow journey checkpoint, related. So that means that pick which assets can be switched, where the person can go. And as soon as they say, well, do it for me, it doesn't allow that to happen because you want to have that very last, maybe a human needs to check it. You can then do what's called the breakout in the world, and that will then break out to, let's say, a human agent that will then have an item popping up saying that this person wants to take action from A to B, and the human can then say yes, phone them and say, are you sure we'll do this, and click the button to get the job done. So you can have a less risk-based environment configured if you wanted to do that, and then you can just scale it to everybody. I mean, you don't have to contain it to just, a few people or, some people. It's not, I'm not sure
Thanks,
that
Jay. And once an agent has now been trained to handle a task like that,
yes.
How many customers how do you estimate or determine how many customers it can concurrently serve, for example? Is that another?
We have got some heuristics that we use for that. And I think that it depends on where your model is hosted, what the interaction cycle is, what the size of the memories of the conversation, how many concurrent conversations you are expecting over time. So all the classical scalability challenges exist out of the box. So you're still going to need to think about those.
Thanks, I got it. Thank you.
Cool, thank you so much. Brings us to the end of our session. Definitely sure to join our session next week. I really enjoyed it. I hope everyone. We have another question. Etienne, go for it.
No, I just wanted to say thanks and apologies that I joined late and disrupted it slightly.
No, you didn't. It's all good. Etienne, I mean, those questions are all very valid. Yeah, it's very good.
Great. Thank you so much, guys.
Thanks, Jay. Cheers, Jace.